The day physics broke, how Google's Willow just changed reality. Mark that date. October 22nd, 2025. History books are going to record this as the moment the world split into before and after. Why? Because Google just did something that shouldn't be possible. And I don't mean difficult. I mean they literally broke a 200-year-old law of physics. For the last century, we've been told that computing has a hard limit. It's called the Carnot Principle, a fundamental rule of thermodynamics that dictates how efficient an engine can be. You can't get more energy out than you put in. It's the speed limit of the universe. Well, scientists in Germany just proved that at the quantum level, that speed limit does not exist. Google's new quantum chip, Willow, didn't just nudge the bar. It obliterated it. It solved a problem in minutes that would have taken the world's fastest supercomputer longer than the age of the universe to crack. If you think this is just about faster video games or better AI chatbots, you are missing the bigger picture. We just unlocked a cheat code for reality. And today, I'm going to show you exactly how they did it, and why the next 3 years are going to look more like sci-fi than real life. The core breakthrough, the Willow chip. Let's get technical for a second. But I promise, I'll keep it simple. The problem with quantum computers until now has been noise. They were like trying to balance a pencil on its tip during an earthquake. One tiny vibration, and the calculation collapses. Google's Willow chip is different. It's operating with 105 qubits, but the magic number here is fidelity. They've achieved a 99.97% accuracy rate. Think of it this way, your laptop makes errors all the time. You just don't see them because it has built-in spell check for code. Quantum computers didn't have that spell check. Until now, Willow isn't just running calculations. It's using something called the quantum echoes algorithm. Imagine being able to drop a pebble in a pond, watch the ripples, and then rewind time to see exactly where that pebble hit. That is effectively what Google is doing at an atomic level. They are scrubbing errors faster than they are making them. This is the holy grail we've been waiting for, below threshold error correction. Okay, cool tech, but why does this matter to you? Because we have hit a wall with classical computers. We literally cannot simulate nature because nature is too complex. Take pharmaceuticals. Right now, finding a new drug is like trying to pick a lock by guessing numbers. It takes 15 years and billions of dollars. Quantum computers don't guess. They simulate the molecular interaction perfectly. We are talking about curing diseases that we assumed were incurable. Or look at material science. Imagine a battery that charges in seconds and lasts for weeks. Or a solar panel that is 90% efficient. We couldn't invent these materials because we couldn't calculate the chemistry. Now we can. Google calls this the molecular ruler. They can now measure distances between atoms that were previously invisible to us. They aren't just reading the book of nature anymore. They are learning how to write in it. The timeline, faster than you think. Here is the part that keeps me up at night. The timeline just collapsed. We used to think practical quantum AI was a 2050 problem. Look at the roadmap now. 2025 was verification. We are here. 2026 and 2027 are for fault-tolerant systems. This is where the machines become reliable enough to run 24/7s. By 2028, we hit commercial application. This is when banks, energy grids, and logistics companies start switching over. And by 2030, we will see hybrid systems. Quantum and classical computers working together as the standard. This is exponential growth. It took us 40 years to get the first qubit. It took 4 years to get to Willow. The next leap won't take 4 years, it might take 18 months. The dark side in conclusion. But I have to be honest with you. There is a reason scientists are freaking out, and it's not all happy news. This is a dual-use technology. The same power that can design a cancer-killing molecule can design a bioweapon that targets specific genetic markers. The same algorithm that optimizes our energy grid can crack the encryption of every bank on Earth in seconds. We are entering an era of quantum haves and quantum have-nots. The gap between companies and countries that master this tech and those that don't will be wider than the gap between the Internet age and the Stone Age. The quantum age isn't coming. It walked through the front door on October 22nd. The question isn't, is this real? The question is, are you ready for a world where the impossible becomes a daily occurrence? If you want to stay ahead of the curve and understand the tech that is actually shaping the future, make sure you hit that subscribe button. We are going to be tracking this rabbit hole all the way down. Thanks for watching, and I'll see you in the future.